This part is made from 1/4-inch mild steel plate. It was laser cut, CNC bent, and powder coated by SendCutSend. Today we're going to walk through the entire process that I used to design this part in Fusion, and maybe you'll pick up some ideas you can use for your projects. Welcome back to Cloud42, I'm James. Well, if you saw the last video, you know we are starting a new project to convert this Precision Matthews benchtop milling machine to CNC using a MASSO touch CNC controller. And today I want to get the CNC controller mounted someplace so that it's off of my bench and isn't going to get damaged as I'm working on everything else, and I can also start hooking up some wiring and getting things moving. Now, I've thought about how I want to mount this. I've seen people mount them onto the machine itself. I don't really like the kind of motion and vibration of the machine moving the display around. I've seen people build enclosures and mount to that. Maybe we'll do that someday. But for now, I'd like to mount it using a monitor arm. It does have a VESA mount on the back. I'd like to mount it with a monitor arm to my toolbox. The problem is there's not really a great place to mount a monitor arm on the toolbox, so we're going to make a bracket. SendCutSend is sponsoring this video, or rather the CNC build project, in the sense that they are providing parts for it. They're not paying me anything to make this video. I just thought some instruction on how to actually design bent plate parts in Fusion would be something that people would find useful. They are, however, paying you. There is a link down in the description, and if you use that to order from SendCutSend, you will get a 15% discount. And I should also clarify, in the last video, I provided a discount code from Precision Matthews for 5% off of this mill. Turns out that's good for all of their benchtop mills. So that's down in the description as well. This is the monitor arm that I plan to use. This is just a monitor arm that was really lightweight. I'll put a link in the description. I just picked this up off of Amazon, and I selected it because the rated weight was about right for the MASSO, which is itself quite light. And I need to mount this somewhere on the toolbox. The way this is designed to work, it comes with this little bracket that has a clamp, and you're supposed to just like set this on a work surface and tighten down the knob to clamp it on. But there isn't really any place on this toolbox that this can clamp. There are screws in the bottom. You can take these out, take this arm off, and you could just put screws into the bottom of this. So you could potentially like just put it on the top of the workbench or on the top of the toolbox. Like I could move this toolbox over and put it on top back here. The problem is the top of this toolbox is just light gauge sheet metal. There's some reinforcing ribs in it, but the metal itself is pretty thin and it's pretty flexible. It's only really strong because you have these big triangulated planes that are in shear. And I'm afraid that if I try to just screw this down or bolt it onto that, I can already see there's a little bit of motion there just from the flexing of the toolbox top. So by the time I have this arm stretched out with weight on the end, that's going to be pretty bouncy. It's going to be pretty springy. So I really want something a little bit more solid to hold it. So the plan is to build a bracket that attaches to the plane of the side and then has a tab that reaches around the back and attaches to the back surface of the toolbox as well, so that it's stable in all three axes, and any kind of force that tries to bend it or force down on the arm is actually going to cause it to have to shear the fasteners that are across the back, rather than just, you know, pressing and pulling on this panel, which will kind of oil can and flex. So we already have 4 holes in the end here with threads that hold the handle on. So my plan is just to measure the locations of those, use those, and then design it with a tab that goes around the back, and I'll put some nut certs through the sheet metal of the back and give it a place to anchor later. And I'll just figure that out after we have the design and have the part in hand so that we can put it in place and mark those locations. So to design this thing, what I'm going to ultimately do is build a model of the toolbox, design against that, so I need to know the dimensions and the location of the holes. So I've got my metric tape measure. Look at that, millimeters for all of you doubters. So we're looking at 460 millimeters wide, and then I can locate these holes. And they don't have to be super precise. In fact, the nut certs that are in the toolbox are not super precise. It's not perfect alignment here, but they're 6mm screws. I'll make 7mm holes in the bracket and it will be fine. It'll be fine. Here in Fusion, I already have a basic design for the toolbox, and I just modeled this up based on the measurements that I took. So it's just a box, but I did go ahead and measure the folded sheet metal lip and the little flange on the outside here at the top, just so that I could make sure that the bracket that I build isn't going to be encroaching on that space. To locate the handle holes, I just created a sketch and used the dimensions that I measured off of the toolbox. I know vertically they're 54 millimeters apart, horizontally 380 millimeters apart, and I measured down from the top and in from the front to roughly locate them. The other thing I did is I put an ellipse around two of the screw holes here in the back, and this is the elliptical plate for the flange that mounts the handle onto the toolbox. I'd like to be able to put the handle back on over the top of the bracket that I make, so I'd like to know how much reveal there is around the outside of that flange, just to make sure that it doesn't look funny, it's not overlapping the side, and it doesn't interfere with any of the bends. So to actually design the bracket, we're going to start with a flange that goes under those handles. So I'll say Create Sketch, click on that side surface, and then I'm going to project some of this geometry. So I'll hit P for project, and I'll select two of these screw holes, and then I'll select 2 points on this ellipse and bring those into the sketch. So I'd like to make a rectangular flange that's centered here. So to center it, I'll hit L for line, X for construction, and I'll just draw a diagonal line between those 2 points, and that'll allow me to use the midpoint of the line to center up my rectangle. So I'll go Create, Rectangle, Center Rectangle. I'll turn off construction. We'll find that midpoint and just drag out a rectangle around this. Now I'd like to have about a 5 millimeter reveal around the edge. So we'll hit D for dimension, select a point, line, click 5 millimeters. And then we'll do that again here. Make sure we pull this out so it's in the right location. D for dimension from here to that line is 5 millimeters. Okay, so now we have the base flange. I'd like to put some slots in here for the screws, and so we can do that with the Create Slot command, and we'll do a center point slot. Just click here, bring that out, make a slot, and we'll dimension this up. Now it's an M6 screw, so I would like to have a 7 millimeter hole. And this is the radius, so 3.5 millimeters on the radius. And then the width of this thing, I'd like to give it a little bit of leeway here. So let's go 5 millimeters. Great. And then I'll just replicate that on the other 4 screw holes. Now that we have that sketch, we could just select that profile, hit E for extrude, and we could make our bracket. But we're not going to do that because we don't want it to be a solid. We want it to be a sheet metal part. So we'll come over to the sheet metal tab and we'll click the flange tool instead, select that and click OK. Though I want to create a new component for this so that we'll have a sheet metal component inside of this solid model. And when we do that, we then need to select a sheet metal rule. And you can select any of these standard ones. We'll come back and change the parameters. Now, I already have one here for SendCutSend mild steel 1/4 inch. So we'll use that, but I will show you how I created that. If we come to the SendCutSend website and click on materials, we can scroll down and see all of the different materials that they offer. I want to use mild steel, so I'll select that. And if we scroll down here on the page, there's a bunch of information, but there is a table of specifications. So I'll come down here and select 1/4 inch because that's the material I'd like to use. Advertised thickness 1/4 inch plus or minus 8 thou. It's hot rolled, pickled, and oiled, and that is exactly what I want. I want to use something that's pretty thick and pretty rigid because flex is something that I'm concerned about here. Could I engineer this with a thinner material? I probably could, but just using something heavier makes it way easier. So if we scroll down a little bit here, we have the bending specifications, and there are a few parameters that we need so that we can configure Fusion to know how the material is going to be bent so that when we make the model, it'll match what actually gets made. The first and most important thing here is the K factor, and that is 0.36, and this is going to vary based on the material and, well, actually the bending conditions and how the material is being bent in the tooling. For their service, it's 0.36. We also need to know the effective bend radius at 90 degrees, and that's 0.150. And we need to know the bend relief depth so that Fusion can put in the right bend reliefs to make sure that where you have an intersection with the bend, there's a gap there so that the material can flow around the bend properly. And that's 0.420. So back here in Fusion, we can look at the component that we created, and I set it up with my SCS mild steel rule, but I can click here and select a different rule. So I'll go ahead and just select steel inch, which is a generic one, and then we can go in and edit it. So you come up here to the sheet metal tab and click on sheet metal rules, and it will pop these open. So there's the mild steel one I already had, and here's the steel inch I just selected. We'll click on edit and open this up. Okay, the thickness is 0.25. The K factor is 0.36. And then if we open the bend conditions, we have the bend radius here, and that is 0.15. And then we have the relief depth, and that is 0.42. And that is it. You can see the flange has now been expanded, so it's 1/4 of an inch thick, and we're ready to continue the modeling by adding some bends. To add bends in Fusion, we use the very same flange tool that we used to create the base flange. Click on an edge and just pull it out. And there are some parameters here that control how this works. Like, where do you want the bend position? You selected an edge. Do you want that outside, inside? Do you want it adjacent? So if it's inside, then this outer surface will be in line with the edge you selected. If you select outside, then the inner surface will be aligned with that edge. And that's actually what I want here, because that edge left that 5mm reveal around the handle flange, and that's exactly what I want. I want this bend to start outside of that. Now, I don't want this to be the full width. There are a couple of ways that you can manage this. You can actually change the base flange and actually, sketch something on this and add a little corner and pull up a little edge that you can then use, but then you don't get all of the planning for the bend relief. So the best way to do this is to select this edge and actually pull this out, and then up here where it says full edge, you can instead say 2 offsets, and now you have offsets that you can drag out and use to control exactly where that flange is. And it's putting in bend reliefs. That's what this is. If instead this little gap wasn't there, then when the metal gets distorted around this corner, around this bend, it would mess up the part of the material that comes out beyond that. So when we set the relief depth, that's what it was doing, is controlling how much space, like how far beyond the bend is that relief cut. So there's one added there, and there's one added here. For this back one, I would like this to come out to exactly the back edge of the toolbox, because I'm going to then take a flange around the back. So I can use the inspect measure tool to see exactly what that distance is. It's 11.25mm. So then I can go back here and change this value so that it matches exactly. I would really like to be able to have something that would allow me to pull this out to that edge. I haven't found that. If you know how to do that, throw that down in the comments. Okay, with those dimensions right, that gives me that. And then I want to bring a flange down on the back here that'll come across the back. So I'll do exactly the same thing. Just click that edge, click flange, and pull that down. And I want to do the same thing here and say 2 offsets so that I can pull this out and create a tab that goes across the back. And you can see that once again, it's added the relief that's needed here. Now, I thought about this quite a bit, and the reason I wanted to do it this way is this gives full support to this little flat surface on the top to support the monitor arm base. It can't flex up and down in this direction because that would require shearing this plane, and if we put a couple of screws into the back of the toolbox here, those would have to shear. So that should be very, very rigid. In this direction, tilting front to back, we have the same thing. We would have to shear across this surface. And so the only real point of flexing would be if you draw a line across here. This corner could flex up and down, but because of this flat surface and it has support along 2 edges, it's pretty narrow and it's a 1/4 inch mild steel. This really should be plenty rigid for what we want. If we went thinner, 3/16, it might be okay. If we went with an 1/8, I think that would be too thin. And then just to belabor the point, because we brought the edge here even with the back of the toolbox and we have this bend located on the outside, that comes down and this surface should be exactly against the toolbox. And that's all there really is to designing a sheet metal part. Now, of course, we're going to need some holes in this thing. We're going to need some slots in the back, and that it's just as easy as, creating a sketch, drawing some lines, putting in some geometry, and using either extrude or the hole command to add those holes. And then we can also hit F, use the fillet command, and come back and round off some of these corners to whatever dimensions we desire. And I, of course, have one prepared that's already done here. Got some nice rounded edges. I've got some nice slotted holes for screws, and I've got the geometry that's required to bolt down the arm base. Now, let's talk about degrees of freedom here, because I'm pretty sure that I'm not perfect. At least that's what people tell me. And so I'm quite certain that I am going to make some mistakes here. So these are M6 screws. So these slots are 7 millimeters wide. So if there's a little bit of misalignment, there's a little bit of motion there. And then I've given them 5 millimeters, so plus or minus 2.5 millimeters of motion in and out. That will allow this tab to sit flush here, or if I got my measurements off a little bit, we can adjust it. Or if the nut insert we use, the threaded insert in the toolbox, sticks out a little bit, or if the metal's bent a little, this will move in and out to make that fit. And then these are slotted in this direction, so if anything flexes as these screws on this flange are tightened, that can move in and out, and it also gives me a little bit of slop in exactly where I'd locate those inserts. The only parts here that don't have very much free play are these holes in the top, and that's because I could measure the holes in the base very accurately, so I'm pretty confident in those, but even though I'm confident of that, I still used 7 millimeter holes for M6 screws. To actually get this part made, the traditional process would be to create a flat pattern, upload that, and specify the bends. And so what you do then is you come in here, select this, go up to the sheet metal tools here, click on Create Flat Pattern. It'll ask you to select a stationary face, and it will create a flat pattern. You can then export this as a DXF file and follow the rest of that process. But if you do that, you have to then specify the bends, and I don't know about you, but on parts like this that are not symmetrical, I nearly always get one of the bends the wrong direction, and then I get a part that's the mirror image of what I need. And so in this case, it would only fit on the left side of the toolbox, which is not what I want. So we are going to skip that, and instead, we're just going to select this component, right-click, and say Export. And then in the Export dialog, we can select Step File, give it a name, and save that to disk. And then over on the SendCutSend website, we just click Upload, select our step file, and it will upload, process it, and it will extract the flat pattern, which is fantastic. Like I said, I've done this before and I've messed it up. So here's the flat pattern. If we click 3D, you can see it already has the bends, and it extracted those from the solid model. I have seen a couple of situations where this didn't work, or it didn't extract one of the bends, and I think the issue was some of the extra geometry that I added to the file wasn't perfectly perpendicular because I had some bends that weren't 90 degrees, but in general, this has worked fantastic for me. So over here on the right, we need to select our material, metals, steel, mild steel, 1/4 inch, click Next. It already has the bends. I don't need any hardware insertion. I don't need any tapping. Click Next, but I would like powder coating. So we'll powder coat, gloss black, and add this to our cart. Now you can see down here it says ships as soon as February 15th. Now if we actually take off the powder coating and say no finish, that's faster. In this case, February 11th. It's currently February 7th. I have found these dates, especially with the powder coating, to be pretty pessimistic. And in general, certainly I can't make any guarantees, but in general, they typically beat these dates by at least a few days.
It's here. Now, in my last video featuring parts from SendCutSend, I made a joke about the candy. They used to include Sour Patch Kids with all of their shipments, and lately I've been getting other things like these Mike and Ike sour watermelon, and these sour punch straws. And I made a joke about it in the last video, and the company actually reached out to me to let me know that they actually prefer the Sour Patch Kids as well, but they've been having trouble actually getting enough of the small single serving packs. So that's why they've been substituting other candies. And I thought that was absolutely hilarious. Let's take a look at what we've got. Well, that is just gorgeous. I knew I was making a part that was going to be really beefy, but this exceeds my expectations. You know, there is really just something about designing something in CAD and then having it made and then just holding the finished part in your hand, going from that digital model to something that's real. This looks great. Now, does it fit? That's the question. Excellent. Let me go ahead and put the other two screws in here. Okay, the biggest risk here was really whether this tab on the back was going to line up, and it looks like I do have enough adjustment to get that in there. Now, it turns out I did make a mistake on the original design that I noticed after I placed the order, and that was that this tab on the back was actually 2 millimeters away from the back of the toolbox. It was a late design change. I didn't have the parameters set up properly in the model, and it just is a mistake. However, since I did provide adjustability in this horizontal direction with these slots, as long as I had more adjustability than I had error in the location of the screws, it was all going to turn out okay. And it looks like it's all going to turn out okay. And just as I suspected, there is a fair bit of flex there when it's only attached. But this tab on the back, once that's anchored, I think that is going to solve the problem. So let me grab a transfer punch here. And then we'll just go back and forth to make a scratch in the toolbox, and that'll give us our location. To drill for the nutserts. Drilling accurate holes in sheet metal can be a real challenge. A step bit can work pretty well, but I actually need a 23/64 hole. That's the closest drill that I have to fit the M6 nutsert or the threaded insert, and I don't have a step drill that actually has the right diameter. This is in 16ths. I don't have one with 32nds. So what I'm going to use are these vortex point drills. And these are like little tiny step points. So they've got a number of steps on the tip. And then ultimately it's just, an ordinary drill. It's a little bit shorter than a jobber drill, but these will locate on the point and then step in progressively to the full diameter without shattering, bouncing around, and hopefully without making a triangular hole. Let's see if this nutserts fit. Oh, they do. Oh, and it's a nice tight fit. That is exactly what I wanted. I'm just using a little Astro 1442 nutsert setter or nut setter. We'll just put that in there, squeeze it, and that should be that. If you've never seen these before, it's just a little threaded insert that expands like a rivet.
So when I squeeze the handles here, you can see it's just expanded, stretch that out, and it bites into the hole. In fact, I could probably go a little bit further than that. When I mount this permanently, I want to actually put the handle back over it as well. Plus, this is an extra 1/4 inch thick steel plate, so I'm going to use longer screws. And I'm going to use washers to try to protect the pretty powder coat, and I'm going to use black screws and black washers because black. I'm so glad those screws went in those holes. Okay, so I'm going to tighten on the back here first, just to make sure this is all snugged up. And then we'll tighten it on this side. And that felt to me like it moved a little, so we'll loosen and retighten these just to let the stress off. Oh, that is beautiful. Love it. Okay. And there's basically zero, it's not zero flex, but there's zero meaningful flex. Okay, let's mount the MASSO on here. This has got holes for 75mm or 100mm VESA, and the MASSO actually has 100mm VESA holes. But for some reason that I will probably never understand, these are just through holes through the back aluminum plate. They've got threaded inserts in here for everything else, but they didn't put threaded inserts in these holes. And yes, I do know it's a little bit complicated because all of these inserts went in from the back, and the inserts for those holes would have to go in from the front, so I guess maybe I do understand the reason. But that would mean that in order to mount this thing, I would have to mess around with individual nuts in here. And I have played around with individual nylon lock nuts, and that is a pain in the... Fortunately, SendCutSend does PEM nut hardware insertion, so I just made a little plate with 4 PEM nuts in it, and I'll just put that in here, and then that'll allow me to have all the nuts captive, and I won't have to hang on to them with pliers. So there, I just ran a couple through from the back, and now those nuts are in there, and that should hold everything in position. Now I can hook those over and put the 2 in the bottom. And I don't have to get to the inside because I have captive nuts now. And there it is. Let me grab the cables. When I bought the MASSO, I bought the wiring kit, so I have this board now that just snaps down over all of the connectors on the controller, and I can hook everything up with 2 DB37 cables. That should be the last time I ever have to open this. Here, I know you want me to. Well, that is what I would call success. I've got this out here on the arm. It's easy to use. I can pull it out where it's nice and accessible when I'm using the machine. I can even pull it over when I'm standing in front of the machine and use it. And when I don't want to use it, it pushes back out of the way. I can even run it in landscape mode if I want to. The MASSO supports that, and I think the rigidity of this arm is gonna be great. I don't know that I would have wanted to go much thinner. I thought about using 3/16 inch plate for this. I thought about doing a few things to, try to make this lighter. I don't think I would do it. I like the rigidity of this, and I am happy with it. I ordered the 3-meter cables, and this is gonna be plenty to reach down to the box on the machine. I'm gonna declare success. Well, if you want to do a project like this, it has never been easier to design something like this in readily available software, order it, and get it shipped right to your door. This isn't really meant to be a SendCutSend commercial, but I really do love their service. If you want to try it out, there is that 15% discount link down in the description. Have fun, make something cool.